Hello, this is Joo-Seung Kim, period 3 for R. I am going to do 2013 AP Calculus BC FRQ number 6. This is a Taylor polynomial, and let's get right to it. We see in the question here, a function f has derivatives of all orders at x equals 0. So this shows us that this is not only a Taylor polynomial, but a Maclaurin, because it's about x equals 0. Now, let's read A. It is known that f of 0 is equal to -4, and that p1 of 1/2 is equal to -3. Show that f prime of 0 is equal to 2. Well, we know that f of 0 is equal to -4. And we know that p1 of 1/2 is equal to -3. We also know from this that p of 0 is equal to -4. So, if we are going to make a polynomial, let's say p1 of x, we know that it's -4 plus a constant k times x. Now, we find from this one that p1 of 1/2 is equal to -3. So this means that k times x is equal to +1, because -4 plus 1 is equal to -3. And if we substitute 1/2 for x, then 1/2 times the constant k is equal to 1. So k must equal 2. So if we read the problem again, it says, it asks you to show that f prime of 0 is equal to 2. Well, we see that because k equals 2, the Taylor polynomial of p of 1, is going to equal -4 plus 2x. This is also equal to f of 0. Or it represents f of 0. So that means f prime of 0, which is represented by p prime of 1 of x, is going to be 2. Cool. Now let's move on to problem B. We see in problem B that it is known that f double prime of 0 is equal to -2/3, and f triple prime of 0 is equal to 1/3. Let's find the Taylor series, the third degree Taylor series. Well, we already found the first two. It is -4 and 2x. So p of 3, is going to be -4 plus 2x, and then the third one is going to be used with the the second derivative, which is -2/3. So it's going to be -2/3 x squared. But because of the x squared, it's over 2. And we see that the third degree derivative is equal to 1/3. So it's going to be plus 1/3 x cubed over 3 times 2. Now, you may be wondering why we have this 2 and this 3 times 2. It seems to come out of nowhere. But if we look at what a Taylor polynomial is, we see that it is going to be the nth derivative of a function over n factorial times x minus a. Sorry, this is an a. So what this means is that we have to divide by the factorial of the power. Why is this? Because when we find the derivative of this, the 2 comes down and cancels with this 2, leaving only the 2/3 behind. And because we want the function to be represented by the derivatives, we have to make sure that this 2/3 always remains constant. So we have to cancel this exponent out with the factorial. So 2 is actually 2 factorial, and 3 times 2 is actually 3 factorial. We exclude the 1 because the 1 isn't necessary, but this is how we usually write it. Now, let's move on to letter C. Let's read the question. The function h has first derivative given by h prime of x is equal to f of 2x. It is known that h of 0 equals 7. Find the third degree Taylor polynomial for h about x equals 0. Excuse me. So, we see that there is a function of h, which the prime of it is equal to f of 2x. And we know that h of 0 is equal to 7. So, the polynomial for h of x is going to be starting off with a 7. And then it's going to add, or maybe subtract, we never know. And we have to look towards f of 2x. So here, we see -4 as the first starting Taylor polynomial. And we see that it's -4 plus 2x minus 2/3 x squared plus 1/3 x cubed over 3 factorial over 2 factorial. All right. Now, because it's 2x, we have to multiply everything that has an x with 2. So this becomes 4x. This becomes 2x squared, right? So it's 4x squared. This becomes 8x cubed. Now, if we put this in here, and we have to integrate it because h prime of x is equal to f of 3 of 2x. So h of x must equal the integral of this. So it's going to be -4x. And we're going to add 2x squared. Notice because the 2 is going to come down, it's going to be 4. And normally we would divide by the factorial, but because the constants cancel out, we can just put 2x squared. And then we're going to subtract. And this time, for this digit, we're going to put x cubed here. And then we're going to do 4 here. And then we're going to put 2 here. And we're going to divide by 2 factorial. Why is this? Well, because if you look at this, the 3 is going to be canceling out the 3 over here. So when the 3 comes here, it's going to cancel out. And then the 2's here are going to cancel out, so this actually goes away. And we have the 4 left. So if we rewrite h of x as a polynomial, it's going to be 7 plus -4x plus 2x squared minus 4x cubed. That is all, and that is all you need to know for this FRQ. This is a very simple Taylor polynomial question, and because the questions are so closely related, it's easy to get all 3 of these wrong. So you have to be careful. However, because it is so closely related, if you get A, you can probably get B. And with these 2, you can solve for C. As we see here, most of the work that we did was done in the previous question, and it was done in the previous question. All right, thank you for listening.